Hello everyone, my name is Anulua and this here are my colleagues.
My name is Muhammad.
My name is Lord Ami Samuel.
We are in front of the Control Systems Research Lab, and this Lego robot, although not the latest generation, is going to be used to implement and demonstrate key principles of control systems, automation, and machine learning such as PID and ANN. But this is the ADL track, and here we have curvitons, we have the sharp bends, we also have a slopey turn, we have a sharp bend here, and this is the stop line here. My first demonstration is going to be I'm going to demonstrate the two-stage line straddle algorithm. Now this robot tracks the sharp bend here, also tracks the slopey bend. It is tracking the sharp bend, also tracks this minute curve, and it stops. Following the reverse track. This reverse track is always sometimes a little bit difficult. It tracks the sharp bend here. It also tracks this sharp bend. It tracks this slopey bend. Tracks this minute curve. Tracks this curve line. And it stops here. The other stages, they are better and more efficient, better result in tracking. I'm going to introduce the my colleague here is going to be demonstrating the three-stage algorithm.
In this three-stage line follower diagram, it involves three stages labeled A, B, and C. And what it does is that three different values are sent to the corresponding motors. In stage 1, labeled A here, a value of -50 is sent to the corresponding motor. In stage 2 rather, labeled B, the value of 0 is sent to the corresponding motor. Also in stage 3, which is the final stage, labeled C, a value of 65 is sent to the corresponding motors. As expected, unlike the two-stage line follower, this three-stage line follower algorithm should give better tracking. We will now move to the track. We will now demonstrate the three-stage line follower algorithm on the ADL track 1. So I'll start the program here. As you can see, it is tracking better on the slopey bends. It is taking more time, but it's still tracking better. On this sharp turn here, it takes more time, it's more careful because it's performing more actions. It's still tracking. On this bend as well, it takes more time, carefully tracking, and it stops. So we will now do the reverse tracking as well of the three-stage line follower robot. As you can see, it takes more time because, like I said before, more actions are performed. But since it's the reverse order, the sensors are doing more work. At this bend here, this sharp bend here, it takes more time. But it still tracks better. Unlike the two-stage line follower, and then it stops. Now, it stops when it gets to the stop line of the ADL track 1. Now, if three stages helps the robot to track the line better, unlike the two stages which we demonstrated before, then adding more stages, that is, allowing the robot to perform more actions, should allow for better tracking. My colleague will now perform the other algorithm named the proportional controller.
Referring to what my colleague has said on the stage follower, the three-stage follower, having additional stages, we can always have better line tracking. But rather, we can always use a proportional controller to improve that situation. Now, a proportional controller having a slope of this range, the proportional controller having this slope will give us better line tracking. And when the proportional controller, the slope is above the threshold value, it gives us higher output motor power. And when it's below the threshold value, it gives us lower output power. So now on the proportional controller, it gives us an output based on the error reading coming from the sensor. Now, once the way the proportional controller works is once it has a sensor reading from the robot, it calculates out an error based on this. Once it gets out the error, it multiplies it with our constant of proportionality back into our robot to give us a smoother transition when tracking the line. And the graph here basically describes the idea of the proportional controller on this slope at the points when it is giving us lower output power, middle output power at the threshold value, and higher output power, which was calculated based on initial guess of the constant of proportionality Kp to give us our minimum points at the interval of 2, 3, and 6. Thank you. The three stage is constricted because it only performs 3 actions, but the proportional controller, based on the error, gives us continuous better line tracking, or a smoother transition rather. So I'm going to start the motor. Now this is the idea of a proportional controller. You see, it gives us smoother line tracking. Even at the sharper corners or bends, it is though smoother transition, but slow, but it gives us a smoother transition within the bends as it goes along the line tracker. Now, going for the reverse. Provides smoother transition, but slow. But this is where we are going to bring in proportional derivative, which my next colleague will come in to talk about. Remembering that this is based on the previous error, and it keeps calculating based on that. So I'm going to now derivative, the PD part of this controller.
The derivative introduced helps dampen the overshoot, while the motor maintains the fast response obtained from the proportional control. This will be demonstrated now. Now following this robot has a better tracking and sloping bend. You can notice that it is quite slow at the sharp bend. This is also a sharp bend, making it also quite slow. And at this slopey curve, it's a little bit fast. Now taking the reverse direction, the reverse track line is over. Taking this slopey, it's still a little bit slow at the sharp bend. This sharp bend is still a bit slow, but it's faster than the proportional control. At this slopey curve, it was a little bit slow. This minute curve and to the stop. Here at Elizade University, we carry out research on industrial applications of robotics, control systems, and automation, such as collision avoidance in automotive industries and automated tasks in the industry, also in irrigation farming. My viewers at home, you are enjoying to partake in the various research activities being carried out at Elizade University. Thank you.